Graph the inequality in the coordinate plane y is less than or equal to 6. So before we get started, let's look at a couple of things. Whenever we're graphing linear inequalities, we do it using the same method primarily that we did when we graphed linear equations. There's only a couple of differences. First of all, depending on our inequality, if it's less than or equal to or greater than or equal to, the points on the line are a part of the solution, so we use a solid line to connect our points. Whereas if our inequality is less than or just greater than, the points on our line are not part of our solution, so we use a dashed or a broken line to connect our points. So our first inequality is y is less than or equal to 6. So since it's less than or equal to, we're going to use a solid line. And since we only have one variable and the variable is y, remember y equals 6 would be a horizontal line through 6. And it's going to be the same with the inequality for our boundary line. We're going to use a solid line through 6 to draw our boundary line. Now, the second difference is that all of our answers aren't necessarily on the line, but they're either going to be above or below our boundary line. So what we can do is we look at our inequality. It says where are the y values less than or equal to 6? Where they're equal to 6 on the line, where are they less than 6? Below this line. So we would shade the region below the line, indicating that all of our solutions where y would be less than 6 would be below that line. Our next inequality, graph the inequality y is greater than negative 4x plus 5. So we know since it's just greater than, we're going to use a broken line. And we always want to write this in slope-intercept form. It'll make it a lot easier in the long run. So our inequality is y is greater than negative 4 over 1x plus 5. I put negative 4 over 1 because it reminds me that my slope is the change in the rise over the change in the run. So in this case, we're going to start at positive 5, which is our y-intercept. And from our y-intercept, the change in the rise is negative 4, so that means we go down 4. And the change in the run is a positive 1, so we go to the right 1. So from our y-intercept, we go down 4 and to the right 1. Now we're going to use the appropriate line to connect these points. The appropriate line would be a broken line since our inequality is just greater than. So we're going to use a broken line to connect our points. Now, there's various ways to determine which side of the line you shade. One way is by using test points, which is totally fine. Another way is to look at your inequality and read from your variable. This is if you have it in slope-intercept form. And it says the values of y that are greater than our boundary. So I come to my y-intercept, which is negative 5. The values on my y-axis that are greater than are above. So that means all of the points that are above this line would be a solution to this inequality. Now remember, the points on the line are not a part of the solution because of our inequality symbol just being greater than. Our next inequality, graph the inequality negative 4x minus 3y is greater than 9. And again, there's many ways that you can do this problem, but I prefer, and I think in the long run it makes it easier if we put this into slope-intercept form. So our inequality, negative 4x minus 3y is greater than 9. We're solving for y, so we start by moving the 4x on the other side by taking its opposite. So that gives us negative 3y is greater than 4x plus 9. So our last step is to divide by our coefficient. Now, since our coefficient is a negative, when we're solving inequalities, if we multiply or divide by a negative, the sense, S-E-N-S-E, or the direction of our inequality changes. So it changes from greater than to less than. And here I have 4 over negative 3, which is the same thing as negative 4/3 x. And positive 9 divided by negative 3 is the same thing as negative 3. So my new inequality would be y is less than negative 4/3 x minus 3. So we're going to start by plotting our y-intercept, which is negative 3. The change in the rise is negative, so we go down 4, and our denominator is positive, then we go to the right 3. So from our y-intercept, we go down 4 and to the right 3. Now again, pay attention to your inequality symbol. It's just less than, it's not less than or equal to, so the points on this line are not included in our solution, so we use a broken line to connect our points. Okay, and also remember, all of our answers are going to be on one side or the other of our boundary. So we look at our inequality and we read it from our variable. Y is less than. So I come to my y-intercept. The values that are less than are below. So the answer would be all the points below our boundary. So we would shade that particular region. Next, we're going to solve a system of linear inequalities. So we have two inequalities. Y is greater than or equal to 4x minus 7, and y is less than negative 3x plus 8. They're both in slope-intercept form, so we can go ahead and graph each one, and we're going to do those individually. So I'm going to rewrite my first inequality, expressing my slope as a fraction, 4 over 1x minus 7. So y is greater than or equal to 4 over 1x minus 7. And my second inequality would be y is less than negative 3 over 1x plus 8. Now, what we're looking for when we're solving a system is the overlap of the shaded region. In other words, which shaded regions would overlap. And I'll show you what I mean in this example. So we're going to graph these one at a time. And again, steps can be different depending on what video you're watching or what your instructor suggests. So I'm going to show you what I do. So I start with graphing y is greater than or equal to 4 over 1x minus 7. So my y-intercept is negative 7. My slope is 4 over 1. So from my y-intercept, I rise 4 and run 1. Now keep in mind, it's important to use the correct line in connecting these points. Since y is greater than or equal to, I would connect these points with a solid line. Okay, so I personally use this approach, and as I said, if someone shows you different, that's fine. So I'm going to indicate with the number 1, because this has to do with inequality 1, what region I would shade. So I'm reading from my variable, the values of y are greater than, so I come to my y-intercept, the values that are greater than would be above. So I'm using 1 to show where I would shade. And I'll explain this more as I go on. Now we'll graph the second inequality. So I start at a positive 8. That's my y-intercept. And my slope is negative 3 over 1. So from my y-intercept, I go down 3 and to the right 1. And again, pay attention to the type of line. Since this is y is less than, the points on the line are not part of the solution. So I use a broken line or a dashed line to indicate that the points are not a part of the solution. Okay, now I'll indicate where I would shade. I read from my variable, y is less than, so I come to my y-intercept. The values that are less than are below, so I would be shading below this line. Now, the answer to this system is where the overlap occurs between the shaded regions. And that's where I see the numbers 1 and 2. So it would be within these boundaries, it would be all these points in here. This region only has 2's. This doesn't have anything, and this region only has 1. So there's only going to be one region where we have the overlapping, and it's that particular region here. So that means any point in that region would be a solution to both of these inequalities. Another system, graph the solution to the following system. 5x plus 7y is greater than or equal to negative 14, and y is less than negative 5/7 x plus 5. So remember, it's a good idea to start by putting them both in slope-intercept form. So the first inequality, 5x plus 7y is greater than or equal to negative 14, isn't in slope-intercept form. We have to solve for y. So I'm going to start by moving the 5x from the left-hand side to the right-hand side by taking its opposite. And then I'm dividing by a positive 7. So the direction of my inequality symbol is not going to change. So it's going to be y is greater than or equal to negative 5 over 7x, and negative 14 divided by 7 is negative 2. So this is my first inequality. And my second inequality is already in slope-intercept form. Y is less than negative 5 over 7x plus 5. So I'm going to start by graphing my first inequality. It has a y-intercept of negative 2, and the slope is negative 5 over 7. So from negative 2, I go down 5 and to the right 7. Now I use the correct type of line to connect. Since it's greater than or equal to, that means the points on the line are solutions. And I'm going to indicate what side I would shade by reading from my variable. The values of y are greater than. So if it's greater than, that means it's going to be above. So all those points above that boundary line are solutions to the first inequality. Now for the second one. This one, my y-intercept is positive 5. My slope is negative 5 over 7. So the change in my rise is negative. So I go down 5 and to the right 7. And again, pay attention to the type of line. Since it's just y is less than, this is going to be a broken line. Okay, so now we shade or indicate where we would shade. The values of y that are less than would be below. So all of these values where you see 2, all those points would be solutions to the second inequality. Now remember, we're interested in where the points are solutions to both. And there's only one area that has both 1s and 2s, and that's between those two boundary lines. So all the points between the boundary lines are solutions. Now this one goes a step further and says, give me one of the points that are in the solution set. So all you have to do is choose any point that's within that shaded region and between the boundaries and list it. Maybe this y-intercept of 0, 3. I could have chosen a point here that's between that point 6, negative 2. All of these points in the shaded region, if you were to plug them in for x and y, would be a solution for both. Graph the solution to the following system of inequalities. Negative 5x plus 4y is less than 12. X is greater than or equal to 0. And y is greater than or equal to 0. So remember, we want to make sure that we put everything in slope-intercept form that we can. So the first equation, negative 5x plus 4y is less than 12, is not in slope-intercept form. So we're going to start by isolating our y by adding 5x to both sides. That gives us 4y is less than 5x plus 12. And then we're going to divide everything by positive 4, which again, since we're dividing by a positive, the direction of our inequality symbol does not change. And 12 divided by 4 is 3. So this is our first inequality. Y is less than 5 over 4x plus 3. So what I like to do when I have more than one inequality that is a single variable, I start with those. So the first one would be x is greater than or equal to 0. So we first start by drawing the boundary line x equals 0, which is a solid line that's vertical, which is really our y-axis. Now, the values that are greater than would be to the right, because if we look at 0 for our x, because that's what we were graphing, the values on our x-axis you can see get larger as I move to the right. So what this did was it eliminated these two quadrants from our answer. So our answer has to be within these two quadrants. So let's graph the next one. Y is greater than or equal to 0. So y equals 0 is a horizontal line, which is really our x-axis, and the values that are greater than are above. So we've eliminated a third quadrant. So our answers to this particular system have to be within this one quadrant. So next, we'll graph y is less than 5/4 x plus 3. So we start by plotting our y-intercept, which is 3. Our slope is 5 over 4. So from our y-intercept, we go up 5 and over 4. And we draw a broken line. Now we indicate where the values of y are less than. So if we come to our y-intercept, it would be below this line. So all of our answers to this system fall within our first quadrant and below that line.